From this video onwards, we are going to discuss an important variant of linear models, namely mixed effect models. To set the stage, we shall start with an intuitive example. Whenever there is an exam, we see that students try to study the past year's question papers. Now, why is it that the students are interested in the past questions? Because they are not going to go back in time and appear for the past year's examination. They should be interested instead in the future questions, right? The reason why they study the past year's question when they are actually interested in the future questions is because there is a relationship between these two, and that relationship is given by the fact that basically the same question setters are going to set both the questions. So these question setters set this question. So by studying this, you learn something about the standard of the question setters, and they are going to set the future questions as well. Thus, students study these in order to get an idea about the future questions. Now, once you see it from this light, you understand that whenever we are studying the past, we focus on only those aspects of the past which are likely to be conveyed into the future. The things that will remain in the past, they are not going to be replicated in the future, are of little importance. Now, basically the same thing happens when a statistician studies past data. So there, the statistician will analyze data. The available data always means it is past data, in order to be prepared for future data when it comes. And the connection between the two is provided by the underlying data generation procedure, whatever that is. And only those aspects of the past data are important that are likely to carry through into the future. For example, if I toss a coin, I would hardly care about the order in which the heads or tails come, because that is not going to carry forward into the future. However, the proportion of heads that will be related with the proportion of heads that we are going to observe in future, because that is part of the underlying process, namely the probability of head. Now let us see how this idea of analyzing only those aspects of the past data which are likely to be carried forward into the future, how this idea influences the way we are working with linear models. So to start with, we shall work with our very familiar example where we have plots and we are showing different varieties of a crop, and we want to know whether the different varieties, suppose we have got two varieties, whether these varieties influence the yield. Now we want to carry this out in a very large scale way, so we do not get enough plots in the same village. As a result, we have to spread out the entire study over numerous villages, and naturally each village might bring its own effect. So we also consider village as one input. So I have got a variety as one input and village as another input, and the output is yield, something that we have already said. Now when we carry out the analysis of this entire thing, what will be the important part of the story? In order to understand that, let's think of one likely story behind this. So we need to attach a story behind the varieties and the villages. So you have got the varieties and the villages. Now it is quite possible that there is some particular variety that is already used by farmers, and the government is introducing a new variety, some sort of a hybrid variety. So we have the regular variety and we also have the hybrid variety, the regular one and the hybrid one. So these are the two varieties and we are studying them. And it is being done in West Bengal. We need certain villages. So various villages are visited and some random villages are chosen. And these villages, say, happen to be some Chandipur, some Barkuti and some Manu. So these three villages are chosen. So I have got I equal to 1, 2 and j equal to 1, 2, 3. Now we know how to set up the model. Typically in such a case, interaction is not a very natural thing to expect. So we have no interaction. So y I j k equals mu plus alpha I plus beta j plus epsilon I j k, I 1 to 2, j 1 to 3, and suppose the number of replication is 5, k is 1 to 5. So what is the natural way by which we have learned to proceed so far? I will estimate mu, alpha I, beta j under suitable assumptions, identifiability assumptions, etc. So at the end of the day, I will say beta j hat is this. Suppose I put the identifiability assumption like summation alpha I is 0, summation beta j is 0. Then I will quote mu hat, alpha I hat and beta j hat and publish that report. Now suppose that report is being read by say the Bihar government. And Bihar government wants to know whether, based on whatever study has been done in West Bengal, whether Bihar government should go for this hybrid thing or should go for or should continue to use the regular variety. So naturally alpha 1 hat and alpha 2 hat, tests like alpha 1 minus alpha 2 equal to 0, all those things are of great importance to the Bihar government. But will the Bihar government care about the beta 1 hat, beta 2 hat, beta 3 hat? Or even if it is done in West Bengal again, will you care about these particular villages? These are just some random villages chosen. So they are like a random sample from the population of all similar villages in West Bengal. You need some villages for carrying out the study, so you chose them. It is of no importance in knowing that the effect of Maina was greater than the effect of this Barkuti village, wherever this Maina and Barkuti villages are. So they represent a bigger population of villages. So you see there is a fundamental asymmetry between this variety and villages. Both of them are inputs. In this model, however, that asymmetry is not reflected because we are merely considering the past data in its own right. But when we consider that the report is going to be read by someone who wants to use it for future data, you will understand that for future data, these villages will most likely not be used. But these things will be used. When you are going to use the consequence of this report, of this study, you will have possibly different villages, maybe different number of villages. But still you will be talking about these two specific varieties. The question is whether we can have a model which reflects this asymmetry in our interpretation of the model.